if I had this declared as non-local and I set the value of val to be val plus 1, if val starts out at 0, when I execute this line of code, it will change this val to be 1. And now we're actually ready to see that. The way I actually execute this is in my main function, what I'm going to do is, so here's a tricky bit. There's one thing that I haven't told you yet, which is important for understanding this. So in Python, functions are objects. So you might remember from 133Y, we learned a little bit about object-oriented programming, and we saw that you can define a class, and then you can make an object of that class, and objects have properties, and you can pass around objects as being values that you set variables to, and so on and so forth. Well, functions are just another type of object. There's actually a class called function. So I'm going to go here and I'm going to def a function called test me. Takes no parameters. Actually, well, let's pass in a parameter. And then it's going to print A. So there's a perfectly valid function in Python. And if I type test me here to look at the value of test me, it's this function test me at some address. But if I say type test me, it says that test me is class function. So this thing here is actually just a variable whose value is a function object. And that means just like I can say A is equal to 6, and then I can print A and A is 6, I can say A is equal to test me, and then print A, and A is now a function test me at a location, which is the same location, you see, same function. So A is now a variable whose value is a function, and I can call it like a function and pass in a value, right? So if I call test me 3, that prints the number 3. If I call A, open paren, 3, close paren, that prints 3. Because it's the same function. So test me is a function that prints whatever I pass in. A is a function, the same exact function, it prints whatever I pass in. And I can pass this value around. I can set a different value to be A now, and then I can call that because that's a function now too. So functions are just objects and you can pass them around just like any other value. So that means that if this is an object, you can return it. So this thing here, this returns val. But what about the return value for make counter? What do we want that to be? Well, we actually want make counter to return a function when we call it. So make counter is going to be a function that optionally takes a number as a parameter and returns a function. And the function it's going to return is going to be inc counter. Actually, the result of, the function it's going to return is going to be inc counter. So this thing here, this is going to define a function inc counter inside of this scope. When I call make counter, it's going to create a function scope with a value, a variable called val defined. And then inside that scope, it's going to create a new function object bound to this local variable inc counter inside of the make counter scope. And this local function here is going to refer to the non-local val, which is defined inside of that scope. And then when I get here, I'm going to return that new function to whatever called it. So the value here that this is going to return is going to be a function. And I can say, for example, inc counter 1 is equal to make counter, and then I'll just use the default here. And let's do inc counter 2 make counter. And this time I'm going to specify a starting value 10. And then we'll do inc counter 3 make counter. And let's do 100 this time. So this thing here, when I call it, it makes a new function and returns it. And I store that function inside of inc counter. But the function that I'm storing inside of inc counter was created inside of a scope where val was set to 0. And then on the second line here, when I make this function, it was created inside a scope where the value of val was set to 10. And then the third time I called it, it's going to make this function inc counter inside a scope where the value is set to 100. And watch what happens when I actually execute these things. So I'm going to print inc counter 1, and then I'm going to print the value that's returned when I call inc counter 1. And then I'm going to do that a couple more times. And then I'm going to do the same thing, but with inc counter 2. And then let's do the same thing with inc counter 3. Okay, so here's where the magic bit happens. And this will blow your mind. But we're gonna figure it out. So let me run it and let's look at what we get. So I have an extra print statement in here, so I get a bunch of extra lines. So let's get rid of this print statement temporarily. And then we'll look at the result. So what do we get? So inc counter 1, the first time we call inc counter 1, it returns 1 because val started at 0 and we added 1 to it, and then it returned that. And then we called inc counter 1 again, and val was 1 because we incremented it previously, and now it's 2. And then we call inc counter 1, and this time it's 3. And then we did the same thing for inc counter 2. So inc counter 2, it started with val is 10. So it added 1 to that and returned it. So we got 11. But now val is 11. And so when we called it again, it goes to 12. And then it goes to 13. And then we do the same thing with inc counter 3. It goes 101, 102, 103. And we get the same results no matter what order we do this in. So for example, if I move this stuff with inc counter 2 up here, I get exactly the same results, even though the order is different. So inc counter 2 goes 11, 12, 13. Inc counter 1 goes 1, 2, 3. Inc counter 3 goes 101, 102, 103. Or if I move this up here to the top, now inc counter 3 goes 101, 102, 103. Inc counter 2 goes 11, 12, 13. And inc counter 1 goes 1, 2, 3. Because the value that's being manipulated is the value of that val here. So when I call, every time I call make counter, I make a new scope that has val defined with whatever value I pass in, or 0 by default. And then when I execute this line, it changes the value of val in that scope, even though make counter has exited already. So I call make counter, it returns this function here, and then make counter exits and returns this value. Make counter is not running anymore, but the scope that got created still exists. And that this val here, there's still a record of that that gets incremented whenever I execute this line of code here. Basically, every time I call this make counter, it's going to create a new scope with val in it. And then it's going to define a new function called inc counter, and then it's going to return that. So this thing here is not just a function, it's a function inside of a scope with its own copy of val. And as many times as I call make counter, that's how many different functions I have with their own scope and their own copy of val. And each of those copies of val is a different copy. So this one is set to 0 initially, this one's set to 10, this one's set to 100. And then these can happen in any order because they're just adjusting whichever copy of val they have in their scope. They're otherwise unrelated. So like if you look at what's going on here when I scrambled it, so first I increment counter 3, which I get 101. Then I increment counter 2 and I get 11. Then I increment counter 1 and I get 1. Then I increment counter 1 again and I get 2. Increment counter 1 again and I get 3. Then I increment counter 3 and it goes from 101 to 102 and then 103. And then counter 2 goes from 11 to 12 to 13. And these can happen in any order. They'll always increment whatever counter they're associated with. So like I said, I run make counter. Every time I run make counter, I get the scope. And then some record of that scope exists when I make this function and is attached to this function. So I define a new copy of inc counter, a new function called inc counter, which has a reference to this one scope that I get from running make counter. And when I return the function, it includes the pointer to the scope. And when I call this line of code in particular, it's changing the local copy of val inside of the scope that got attached to the function when I made it. And that's called a closure. So a closure is when you have a function that's defined inside of a scope, and the function refers to a variable that's defined inside the outer scope.